This video has to do with significant figures. To begin with, we want to talk about the nature of numbers. So there's exact numbers and approximate numbers. Exact numbers are what mathematicians usually deal with and what we come across in math classes. So there are these ideal, perfect, theoretical numbers that are infinitely precise and infinitely accurate, like 1, 2/3, -17, the number pi, and the number e. So pi is one of these perfect numbers. We're used to thinking of it as 3.14, but that's just an approximation. That's rounding it off. The number pi itself is infinitely precise and infinitely accurate. Approximate numbers, on the other hand, are what we usually see in classes where we're applying the math. So engineering classes, science classes, technical classes. One of my welding students says that this came up a ton in her class, in her welding class. So approximate numbers are measurements. So here's an approximation of pi, 3.1415926. It's rounded off. It's still an approximation. It's not an exact number. Also, the number 72. I should have put some units here, like 72 centimeters or 72 pounds. So measurements are always going to be approximate numbers because we can't measure anything with an infinite level of accuracy. Why do we care about this? Numbers, the size of them makes them more or less meaningful. So in this example, we're saying there's a 5% incidence of illness in a group of 20. And what that means is that one person is sick. Is that meaningful? Is that significant? Well, I guess it depends on how accurate our test is, but it's just like, you know, sometimes one person gets sick. No big deal. It doesn't necessarily indicate a pandemic, right? But a 5% incidence of illness in a group of 20,000 means that 1,000 people are sick. And all of a sudden, that's something that we probably should pay attention to a lot more. If we changed the percentage, if we said, oh, well, 4.9% or 4.29%, as we really dig in here, that changes the level of significance of our answers. So let's talk about significant digits, and please just ignore this section number. So for all approximate numbers, meaning all measurements, the number of significant digits and where those digits fall, which is the precision, we'll get to that in another video, determine how we round our answer. So we need to talk about the rules for significant digits. First rule, all non-zero digits are significant. So 258 has 3 significant digits, the 2, the 5, and the 8. All zeros between significant digits are significant. So since these zeros are sandwiched in between the 2 and the 7, they are considered significant. So this has 4 significant digits. All zeros at the end of a decimal number are significant. And a decimal number is just a number with a decimal, like 5.2. So since these zeros are at the end of 2.000, that means there's 4 significant digits there, the 2 and then the 3 zeros. However, the zeros in front are not considered significant. So 0.09500 also has only 4 significant digits. So those first 2 are not considered significant. Some more digits that are not considered significant are zeros at the beginning of a decimal number, kind of what we just talked about. So 0.0120 has 3 significant digits, the 1, the 2, and the 0. Meanwhile, 0.5300, those last zeros are at the end of the number, which means they are significant. Also not considered significant are zeros at the end of a whole number. So 36,000, it looks like it's highly significant because there's those, it's a big number. But there's only two significant figures here, two significant digits, the 3 and the 6, because the zeros at the end of a whole number are not significant. I understand this is a little confusing because over here we talked about the zeros at the end of a decimal number are considered significant, and here the zeros at the end of a whole number are not considered significant. To add to the complexity, there is an exception here. Sometimes we do what's called tagging a digit, and it looks like a little bar over the number. So those barred numbers are considered significant digits. So in this case, the 360 are significant, but these two trailing numbers that are not barred or not signified, not tagged, are not considered significant. 36,000 with the bar over the hundredths place has 3 significant digits, the 3, the 6, and the tagged 0. If we had 36,000 with a bar over the tens place, that would have 4 significant figures. Because the 3, the 6, the 0 in between, and the tagged 0 are all significant. This last 0 is not. All right, again, ignore the section and ignore time for a poll in Zoom because obviously this is a video. So I want you to attempt these 6 questions and just jot down how many significant digits the following numbers have. Pause the video and I will tell you the answer. This first one has 3 significant digits. The 0 is in between 2 significant digits. 31.00 has 4 significant digits. Zeros trailing a decimal point are significant. The third one has 2 significant digits because that first zeros in front of the decimal number are not considered significant. Number 4 is fun because the 3, the 1, the 0, and the 0 are all considered significant. The leading zeros are not considered significant. So again, zeros after a significant number at the end, not zeros before with a decimal point. Number 5, only the number 2 is significant. None of those zeros are tagged, which means the number 2000 only has 1 significant digit. By the way, I'm using significant digit and significant figure interchangeably. The last one, the 2, the 0, and the 0 are all significant. The 0 in the tens place is significant because it's tagged, and the 0 in the hundredths place is significant because it's sandwiched in between 2 significant digits. There are 3 significant digits in 2000 with the tens place tagged. Thank you, and please let me know if you have questions.